All right, now we're going to look at how we, this is sort of supplementary material for how we find the partial fraction decomposition that we needed in the last example. And that would be example 4.14. So the first fraction that we were working with was 4 over s squared plus 1 times s plus 2 times s plus 3. So the s squared plus 1, that's a quadratic, so I'm going to put an arbitrary linear up top, as plus b over s squared plus 1. And then s plus 2, that just gets a constant, c over s plus 2, and then d over s plus 3. We multiply through by the LCD, and we find that we've got 4 equals as plus b times s plus 2 times s plus 3. And then we have c times s squared plus 1 times s plus 3. And then we have d times s squared plus 1 times s plus 2. Now there's some low-hanging fruit here available to us. If s is equal to negative 2, then on the left side we have 4. And if s is equal to negative 2, the first term, anything with an s plus 2 will zero out. So that's the first and the last terms. And if s is negative 2, we're just left with c times 5 times 1. And that tells us that c is 4/5. And if s is equal to negative 3, then everything with an s plus 3 zeroes out, and we get 4 equals d times 10 times negative 1. And that means that d is 4/10, or negative 4/10 or negative 2/5. So we know c and d. What we're going to do now is find another convenient value to use along with our known values for c and d. So if s is 0, then looking at this first term here, if s is 0, then the a term, that zeroes out, and we're just left with b times 2 times 3. We know the value of c is 4/5, and if s is 0, then that's 4/5 times 1 times 3. We know the value of d is negative 2/5, and if s is 0, that's times 1 times 2. So we have, and let's see, that was the left side, so this was all equal to 4, right? I'll just write that on the other side. So now we have 6b plus 12/5 minus 4/5 is equal to 4. So 6b minus 8/5, plus 8/5 is equal to 4. That means that 6b is equal to 4 minus 8/5. That's 12/5. And if we divide by 6 or multiply by 1/6 on each side, 6 goes into 12 twice, so we get b is equal to 2/5. So the only value left to find now is a, and we know b, c, and d. So let's say if s is equal to 1, then on the left side we always have 4. This gives us, if s is equal to 1, then that first term, as plus b, if s is 1, is just a plus b. So that's a plus 2/5, because we now know that b is equal to 2/5. S plus 2 is 3, s plus 3 is 4. Let's see, c is equal to 4/5. and then that's going to be times 2 times 4, and then D is negative 2/5, and then that is times 2 times 3, and now A is the only unknown. So we have A plus 2/5 times 12 plus 32/5 minus 12/5. And just basically doing a bunch of arithmetic and a little algebra here. We're going to distribute that 12, so we got 12A plus 24/5 plus 32/5 minus 12/5. And this gives us 24 plus 32 minus 12 is 44/5. So 12A is 4 minus 44/5. We get negative 24/5 is equal to 12A. And then if we multiply by 1/12 on both sides, 12 goes into 24 twice, we get negative 2/5 for A. And this is the partial fraction decomposition that we were looking for and that we used. So A was negative 2/5. We found that B was 2/5. C is 4/5. D is negative 2/5. And these are the values we found, or that we used in the last example.